Good morning or good afternoon, I guess wherever you're at this beautiful day. We'd like to welcome you all to our webinar here. We are pleased to have with us Kevin Speed from industrialEnet. We are pleased to be working with industrialEnet together, helping to find and fill security gaps in large area perimeter security around critical infrastructure. And that's what we're going to be talking about today. industrialEnet has been putting together some unique solutions with a number of different manufacturing partners, us included. And so what we're going to be covering today is some of those security gaps. And first, Kevin, if you want to give a little bit of background on yourself, and then I'll get into mine a little bit later.
Sure, that sounds great. Thanks, Logan. Welcome, everyone. So my name is Kevin Speed again. I'm the Chief Solution Architect for utility critical infrastructure security for IENet. And really, my job is to lead our solution development efforts and delivery to market, focused specifically on perimeter intrusion detection systems. So IENet, for background, is in reality we're a value-added reseller from a sort of structural standpoint, but in reality, what we do is we deliver solutions focused on critical infrastructure security, specifically around perimeter. So, in a way, we're in the truest sense of the form, we're an integrator for integrators. We focus on very close collaboration with vendors to package solutions in that high-end critical infrastructure space, and they would deliver that to the market via integrators, ultimately to end users in critical infrastructure.
Thanks for that introduction. And we've worked together over the years for quite a long time, and excited to be able to introduce kind of some of the new stuff that's happening that we're doing together as well. And first off, industrialEnet will introduce some of their unique solutions that they're bringing, and then we'll dive into how we work together and also some of the new announcements and new products that Spotter is bringing. We just did a major press release just yesterday. And we'll cover a little bit of that today as well. So Kevin, the floor is yours.
That sounds great. Jamie, do you want to go ahead and share the slide deck?
Yes. Yes, go ahead.
There we go. Can you see that okay?
You're good.
Great, thank you. So what I'll be talking about today for the next 15 or 20 minutes is a new solution that IENet is introducing to the market, starting with CUAS and then really in earnest after the show here in the next couple of weeks. So the use case for the solution is really gunshot detection, and really gunshot detection, situational awareness and response. So often, many critical infrastructure facilities throughout the country on the tier 1, high NERC type substations have shot detection as part of their NERC requirements. Oftentimes, though, they don't have a way to understand if shots are fired at a substation. They don't understand or have the ability to ascertain where the shot's coming from and really who's doing the shooting. So it requires really more than an alert. And operators need to quickly understand, one, where the shot came from, two, what assets are at risk, and then what camera or countermeasures should respond. In those environments, oftentimes, especially in the greater West with wide open areas, the law enforcement response may be delayed significantly, sometimes on the order of 1 to 2 hours. So our new product, IENet Converge, is a command and control system centered around shooter detection that helps close the gap between detection, visual verification, and controlled response. The key here in the solution is really is that it's an integration between shooter detection, specifically boomerang shooter detection systems in this case, and pan tail zoom control and countermeasure response. appropriate to the incident. So in effect, IENET Converge takes shot detection data and turns it into real context for the operator. It ingests boomerang event data in the form of coordinates. It gives the operator immediate visual and geographic context by presenting the shooter location on a map, and then presents that in the VMS workflow. The key thing to understand here is that while it's a command and control systems, it's very specifically designed to operate at the site level. That is, the system runs on site, on-prem. It's designed to operate in an enterprise environment, and is specifically designed and optimized around feeding into existing VMS systems. It then triggers automated or semi-automated response actions. So in effect, the shot's detected, the event is plotted on the map, fed into the VMS, and then a pan-tilt zoom camera or countermeasures slews the target. The operator can verify what's going on with the event, both on the map that have physical context with regard to geography and all that, and then also from a video standpoint, and assess the situation, and then enact countermeasures. Here's a view of the workspace or configuration space. And really all it's showing you is, in this particular instance, 5 different LRAD devices configured in the system, a map that's brought into the system. It's actually a 3-dimensional map. It helps us, it doesn't look like it, but it has geo-context data that allows us to, when we aim the devices, both pan-tilt zoom cameras and LRADs, it allows us to compensate for hills and valleys and terrain. And then you have your drivers on the left-hand side. Yeah, Logan.
One comment, Kevin. Maybe you can explain to those who aren't familiar with what LRAD is.
Yeah, thank you. So actually, with that, I'll go down a couple of slides. So an LRAD is a long-range acoustical device. It's actually designed as a hailing device, originally as a hailing device in the marine space. So it's commonly used on naval vessels. You have different versions of them. The particular one that we've developed our solution around is called the 950 NXT. You'll see here 2 speakers, right? They put out 155 dB of high clarity audio for hailing at long distance, up to 3 kilometers. 12 million candle power focused white light, and then a laser dazzler. It's not depicted on this particular unit, but on the right-hand side, as you're facing it, you would have a laser dazzler. And then on the left-hand side, you have a fixed color camera as basically a bore sight or a sighting device. It's used to get people's attention. In this particular application, in the critical infrastructure space on land for substations and so forth, it's used as a countermeasure. So if you have a shot, and I'll just kind of go back to here, if you have a shot incident happening, say, 200, 300, 400 meters, even 500 or 600 meters away from your facility, shots are coming inbound. The boomerang system tells you where the shots are coming from with a high degree of accuracy, both azimuth, range, and elevation. Then we can bring a camera around to target and bring an LRAD around to target. Operator assesses the situation and initiates a controlled response. The reason we developed the system was very customer driven. We have a client who wanted to use LRAD, but there was no control mechanism by which to instantiate or use an LRAD in a controlled and safe manner. So the solution is really centered on safety at its core, and so it's zone based. So if a shot comes from, say, this particular geographic area over here, what's called that zone 1, then LRAD number 1 would respond to all shots emanating from that particular area. You could have zone 2, shots emanating from zone 2 would be responded to by LRAD, say, number 2, PTZ number 2, etc. So it's really a zone-based control system, and each zone can have its own recipe of response. So let's say zone 1 happens to be in a neighborhood type area. You don't want to use really loud audio in a neighborhood for whatever reason per SOP. Then you could limit the audio response to some relatively low decibel level that still is able to be heard over there, but not in a really super loud or invasive way. But you would allow bright white light or laser dazzle or so forth. Another, for instance, would be, hey, I don't want to shine a bright white light down a highway at a close angle that might blind someone at night and cause an accident. You can limit laser dazzle or bright light response in that area, but allow high decibel audio, because high decibel audio is not going to cause a problem with your neighbors on the highway like that.
And we've used some of these before, and they're quite impressive. You can be hundreds of yards away, and it's like the voice of God speaking in your head. It's It's really quite, when it comes to kind of like deterrent and non-lethal deterrence, I mean, it's an excellent tool.
Yeah, I'm glad you said that. In fact, the and I forget the term, but the audio clarity of the LRAD at volume, 155 dB of sound is extremely loud. It's like gunshot, firecracker explosion type loud. The audio clarity at range is so good that it's actually legally defensible in a court of law to say, hey, look, if I spoke to someone via this LRAD and they were a kilometer away, I can certify that they did in fact hear me with a clear tone. It's designed specifically for hailing from ship to ship. Hey,
Yeah.
We're on a collision course and so forth. Or hey, you need to stand down. That type of thing. The general flow of how the system works is a shot is triggered, or an event is triggered based on a shot. Pan-tail zoom camera slews around. We support multiple camera manufacturers and models. The LRAD would also slew to target. The operator can assess the target or the situation both from a pan-tail zoom camera from, say, one angle if it's positioned at a different spot than the LRAD, but also via the LRAD's viewfinder, which is right here. So we present all that into the VMS. The operator assesses the situation, and then the operator responds accordingly. The LRAD has the controls operate native to the VMS. That is, it's our command and control system, INET Converge, is ONVIF compliant or ONVIF compatible. So in effect, you let's say in Genetec, as a for instance, you treat the LRAD device, which is really our server controlling multiple LRADs, you treat that as a pan-tail zoom camera. So as you drag and drop on the screen to follow the target, you treat it behaves just like a pan-tail zoom does, where it intuitively navigates back and forth. It also has joystick control as well if the operator or the end user prefers a joystick type control. Any other questions around the application space, application need, or the LRAD or the software itself?
There was a question about what's the approximate price of an LRAD.
So MSRP to an end user is on the order of around $300,000.
So kind of steep.
It's pretty steep, yeah.
Yeah.
Very applicable for situations, for your higher end situations like tier one substations. Again, the use case is designed around, hey, look, law enforcement response is on the order of 1 or 2 hours, and I have a critical facility that's going to bring down the grid. If I don't do a response, it's going to cause a major problem. Very squarely focused in that space. Hydro facilities as well. I can see it being applied on a big dam where you have a buoy line several hundred meters out and you want to warn people off of it. And that MSRP includes all the options. So laser dazzler option, white light option, full audio, the whole thing. You can actually buy it with just audio only, without the laser dazzler and without the white light, and that would pull MSRP down to probably on the order of around 225, somewhere in there.
So I also had a question, or maybe we can discuss a little bit in terms of integration. Like for our system, Spotter, we also have our own small C2 system that controls and manages multiple sensors and CUAS pan tilt. If they were to coexist, then what type of VMS you were mentioning earlier that you're using interfacing into VMS systems like an existing VMS? Could you speak to how that would work, and also which VMS systems you're supporting?
Yeah, certainly. So right now we support Genetec, fully validated in Genetec. We're positioned to support Milestone as well. That is, it's internal, but it's not been launched yet. So we've done some internal testing. The way that integration would most likely work is that we would actually use the VMS as a conduit. And so say a spotter ground radar alarm comes inbound, we would bring that alarm into the VMS, and then we would associate that with a zone. Hey, spotter zone number 1 has a intrusion alarm. We would bring that into the VMS as an intrusion alarm for zone 1. We would then feed that, because our system talks to the VMS via ONVIF. We would feed that assignment or preset to the control system, and it would bring LRAD around to a fixed preset for zone number 1. That is, it's not recommended, generally speaking, to control an LRAD in kind of a real-time follow the target kind of manner. You'd have to have zero false alarms in order to do that, because you can actually wear the device out if you're constantly automating it and jogging it around and moving it, 24 hours a day. It's not really built for that. It's really best designed or best used for fixed preset response. But that's how that integration would most likely flow, is via the VMS, bring a radar alarm in, or any other system alarm in for that matter, perimeter alarm for, say, a thermal camera, normal VMS type function. That alarm lands into the VMS. LRAD's assigned a preset. It goes to perimeter. And in fact, that's how we're using it. Both it's dual response, that is gunshot response, but also VMS-based preset response.
So the VMS can send a preset signal to the LRAD to cue it to a certain preset, but not auto track it continuously.
Correct. In theory, we could do that, but we haven't seen that use case really be necessary yet.
So we got another. Oh, sorry.
That's okay. I just want to underscore and stress our focus is really on semi-automation of the LRAD, what I call operator assist, which is have an incident, get the LRAD or the pan-tilt zoom camera to the right spot. And because of the nature of the device, you don't necessarily want to, it'd be highly unlikely to want to automatically issue 150 dB of sound, 12 million candle powers of white light, laser dazzle in a fully automated way. The idea is to give the operator everything they need to then assess the situation and then respond accordingly.
So we got another question kind of related to connection and power to the LRAD. How do you power it, and how do you communicate to it?
Sure. So it powers via DC, believe it or not, 48-volt DC, and it's of interest. It's actually this box up here is really an assembly of disparate systems. So you have an audio system, a white light control system, a camera control system, and then a laser dazzler control system. They all come together in this proprietary Genesis, is the manufacturer of the LRAD, proprietary control board, because all these devices really communicate serially. And it also has a network hub in it that is Ethernet, so it communicates via Cat6 Ethernet.
Roughly how much power do you have to supply? How many watts?
Maximum, if it's panning, tilting, zooming, all devices are activated and functioning at one time, the maximum is to around 1,300 watts. The nominal in reality is on the order of around 600 watts or so for normal usage.
Yeah, so a little bit overpowered for PoE plus, or plus
yes.
plus even, but still, doable with the 48 volts DC. That's pretty interesting.
Yeah, it puts out a lot of energy. We do the designs obviously for the control panels and the systems to put it out the door, because we deploy a turnkey. But we ended up doing two industrial power supplies running in parallel in order to actually support the device. We couldn't find one big enough in a standalone single power supply.
So got another question about what's the IP rating of the system, especially the speakers.
It's, off the top of my head, I apologize, I don't know, but it's designed for marine environments. So I would imagine it's probably IP69K.
So it probably do pretty fine on, if it's made for maritime, then it's going to do fine on the land.
Yeah, absolutely.
Okay.
The usable service life from the manufacturer for the device, if properly maintained, that is once a year, preventive maintenance checks and services, is on the order of 10 years.
So there is kind of like a yearly maintenance schedule.
There is, yeah. And really what that is just getting ahead of looking at, it's an annual inspection, and when the maintenance done by the manufacturer, and they go and look at all the seals and gaskets, and it's really a seal and gasket check to make sure everything's nice and airtight and watertight, and getting ahead of that. So, and what they'll do is they'll go do an annual inspection, and that's actually required for the warranty, for a extended warranty, and then they'll give you recommendations. Hey, order this seal kit, this seal kit, this seal kit, and do the replacements, and then do it that way versus reactive.
Oh, that's a good idea. Makes sense.
Mm-hmm.
Do you have anything more that you wanted to cover on this?
No, the only other thing is we took pains in the operator experience, and this is straight off what the operator would see in their Cameo within their VMS, where we really try to give the operator as much information as they can to understand what the working state of the LRAD is. So in this particular instance, you can see that this particular LRAD is disarmed, If you were to arm the LRAD, it would say armed, and then max beam, that which is the white light on or off, laser dazzler status on or off, and audio on or off. This indicates here the sound pressure level at the target. And one thing I'm particularly proud of our team for developing, to be honest with you, is that this, if you'll notice here, this little dot on the LRAD field of view indicates where on the ground the focal point of the audio and light and laser dazzler response is. And that matters because if, for instance, we had a hillside right here, like a steep hill, we compensate for the terrain in the system so that that dot, if you were to aim it onto that hill, or kind of tilt it up onto the hillside, that dot would not move outward. It would stay stationary, even though because it's moving up the hillside. So it provides real context and kind of awareness and really allows you to understand, hey, just because the LRAD looks like it's aiming to the horizon, in which case the target would be experiencing very low audio effects because it's at infinity basically. It's really saying, hey, look, because the target is on the hillside, is experiencing right now 113 dB of sound. This is really important for the LRAD. In addition to the zone control, to say, hey, look, you're not allowed to instantiate white light or laser dazzler aiming, parallel down a highway, or you're not allowed to issue or put out 155 dB of sound because you can actually hurt people with it if you're not careful. You can cause some real problems from an auditory damage standpoint. And so really the control system, while it's obviously the use case is designed around response, the underpinning of the entire system is designed around safe response. And so that's really what the control system is all about, is really safe and managed responsive and LRAP. Final slide just for highlights, and I'll conclude with this, unless there's any other questions. It's a BMS agnostic approach that's really critical to understand. The entire approach has been optimized around trying to provide a single pane of glass that is not a separate workstation, not a separate GUI that has to pop up, not a separate widget or tab. It's really designed to bring it into the normal BMS operator experience. It's multiple camera driver capability. We support Bosch PTZs, Pelco, FLIR, Axis, and Hanwha. We support integrated logic across cameras, LRADs, and even input. So we can bring in easily, say, an input, Logan, to your point earlier, a command from a spotter into the VMS into the system. And we can also support other commands inbound to the system as well. It's relatively easy. We support integrated, we support zone-based LRAD response to radar incidents by way of converged and VMS presets. And it's flexible enough to be customized for customer workflows. This is an important point. This system, I would imagine it would be highly unlikely for us to deploy this system into an end user environment without needing to customize it per customer SOP. That is, it's designed specifically to be customized to match customer operating requirements and limitations, to include the user experience to a certain degree, but certainly the configuration of zones and how the enterprise wants the system to respond. It is also enterprise hardened and very manageable from a cyber compliance standpoint. And with that, that's all I had.
On mute. So we've got a couple more questions, Kevin. One was, does it fall under ITAR, the LRAD?
Yes. Manufactured in San Diego, California, used by the U.S. military and other naval militaries around the world.
So it's been used by other militaries besides the United States. Has it been used by others?
Correct. Filipino Navy, European navies. Yes, it's pretty popular in the naval arena.
And then we got another question talking about the LRAD device. If it's part of a group of units, or can you have one unit be able to be used across multiple zones?
Yes, absolutely. You can have it's specifically optimized around having 3, 4, 5, 6 zones assigned to a specific LRAD. Because if you go back to the map, here's for instance, this LRAD, if it were on a tower and say in the middle of a facility, you would have what I would call a limitation zone. Hey, maybe no response allowed whatsoever on the highway for whatever reason. So it's null. You can aim it there, but you're not allowed to do anything. And you can escalate. We have escalation capability as well, primarily via the VMS. So we say, look, operator 1 is not allowed to respond in that zone, but we want to allow operator 2 to respond. And you could also have a zone that's say, hey, audio only, no light, no laser. Another zone that's no audio, lights, and lasers. So it's specifically designed to have multiple zones per LRAD.
Very good. All right. If there's not any other questions, I'll switch over
Great,
and
thank you.
talk about some other security gaps. Thanks, Kevin. That was really informative. You know, gunshot detection and also the response aspect was very interesting. And we've used these LRADs before, like at dams as well.
Yep.
And it's quite effective. So it's good to see more of that coming in. Like you're saying, one of the main points is to make sure you can deploy it safely, especially if you've got neighborhoods. So that's a good value that you're presenting there. Okay, I'm going to switch over and share my screen here, and let's switch that up. Okay. Is everybody able to see my screen? Kevin, can you,
yes.
does it look good? Can you see it?
Yeah, it looks great. Thank you.
Okay. So this is kind of the new thing that we're starting to see in the market. Well, not in the market, but in the world is threats posed by drones. Obviously, Spotter has been doing, ground targets over water targets, boats, people, vehicles, detection and tracking with ground radars for a long time. We've started doing drones almost within a year or two of starting as a company. Started people saying, well, if you can track, people, why can't you track these small flying drones? This is becoming even more and more an issue, as we can see drones being used in all kinds of different warfare, and as well as, the high flying Shahed drones that you're seeing that are flying, at high altitudes, 200 kilogram drones. There's also these new drones that came out at the end of 2024. And these are fiber optically guided drones. So these are fly-by-wire, small FPV drones that carry a payload, and on them they also carry a fiber optic coil. This is just a really small piece of strong, flexible glass that spools out the back. And these were first introduced with 10-kilometer range. Now I got 20 kilometers. I need to update my slide because they're 60 kilometers, and they're pretty much available off the shelf. So this is Alibaba, and you can see here I can buy a fiber optic cable kit here with 30-kilometer range for $300 and get it shipped to me within a few weeks. That's where we're at right now. So we went from, Russia first, testing these out in the end of 2024. A year and a half later, you can buy these on Alibaba for $300. That's the type of security threat that now we're facing, not just abroad, but here at home. And it's difficult to deal with these. One of the aspects about this is that these are not detectable by RF sniffers. There is no emissions. Come back to this one. They fly just feet off the ground. They're totally FPV. They can't be jammed. They're not using GPS, and they can take a 1 to 3 kilograms, so that's like a 6-pound payload, and they can fly it these great distances. So you get long standoff, no detectability for RF. There's no jamming. There's no jamming response to this. The other new technology that is getting deployed, and we saw this in the Spider campaign that was launched by Ukraine against Russia, where it was remotely launched and then video AI guided. So again, no RF emissions, You can't jam them. They're not using GPS for navigation. They're using AI instead. And with that, they can move pretty fast. They look at the landmarks to get their orientation using video AI analysis of the video stream off their camera, and they're programmed to go find a particular target, like an airplane, and run into it. So these are new technologies that are getting deployed, and it's just a matter of time before we start seeing these. I've already started to hear reports that these are being used in Latin America. Haven't heard any cases yet in the United States, but it's just a matter of time. So, what can we do to plug these gaps? Spotter has a technology stack that is built to detect, monitor, classify, respond to these types of threats. We've got a number of different radar systems, both for ground, air, and we've recently released the remote drone ID, which picks up those that are compliant drones, meaning that they are kind of off the shelf. They're not these fiber optically guided drones, that type of thing, but rather these FAA compliant drones, kind of run the mill, off the shelf. What's new is this. We just released this. It's built on a new technology that we've been working on for the last few years called Compact Holographic 3D Radar Technology, or CH3D. And what it is it is a radar system. You can see, I guess I'm kind of low. I might blow that up a little bit bigger so you can see the actual one behind me here. And what it is, it's a little bit bigger radar system, 16 inches by 10 inches by 4 inches thick. And what it does is it fully illuminates the full field of view continuously, and then takes in essence a snapshot, kind of like you would with a camera exposure. It does that every 56 milliseconds and evaluates all the targets inside the field of view every 56 milliseconds. To kind of put it into the context, in the optical realm, this would be something you would compare to the CH3D, the Compact Holographic radar, as a floodlight, where it's illuminating the full volume of space with a 90 degree by 90 degree field of view. So wide vertical, wide horizontal. It illuminates that field of view 100% of the time. The kind of legacy electronically scanned arrays, they take a different approach. Their approach is to get more range, and in order to do that, they focus the energy into a small beam, like a flashlight. You can see the illustration here of that. And then you scan that flashlight around, across your field of view. The trade-off to that is it takes a long time if you think about it. So one of our competitors has 180 spots in their field of view, and about 10 milliseconds per spot. It takes them 1.8 seconds to go through the full field of view. Unlike the ESA, the electronically scanned array, the holographic radar system is illuminating that and then collecting that energy that's reflected back from the drones or whatever the targets are, and then evaluates that full volume of space in that one single frame. So that's why it's able to then evaluate up to 50 targets every single time that it captures that frame. So every 56 milliseconds. So if you look at it from a camera perspective, most people are quite familiar with cameras, that is 18 hertz. So every 56 milliseconds, so 18 times a second, it's doing that full evaluation and tracking and updating the the track information of all the targets within the field of view every time it does that. So that really what's to set this apart. So let's take a look at some real stuff. I'll bring up a system here. I'll share my screen here on this. To kind of give you an illustration here. We run a comparison of trying to use a camera versus using the radar and see how easy it is to spot two small FPV drones that are flying at about 60 miles per hour coming in. See if you can spot them. If you know where to look, there's a second drone there. If you didn't miss it, I'll back up a little bit, try it again, so give you another chance here. But now with the radar technology, it's able to pick it up and give, precise GPS coordinates. And these are, small FPVs, drones, about a range of 250 meters on a small, less than 1 kilogram, 500 meters on a 3 kilogram drone. So that's now live on our website. I also want to bring up here one of our live systems. Okay. Now this is the new user interface for the Compact Holographic 3D radar system. We've gone full 3D with this. You can, with the first person field of view type of view, we can pop up, look at it from the top down or face forward, move around, zoom around in it. This is all operating within the web browser here. We can pop up, look at the track information on these. I'd like to point out how quickly the update rates are. We measure constantly the lag of the latency through the whole system, and this is for going through everything. The web browser, the network. We're looking at about 58 milliseconds there on the latency through the whole system.
And Logan, how well does the radar work in misty conditions? We have a question in the chat.
Yeah, so foggy and misty, that's one of the real advantages of X-band radar systems, is that they're using a longer wavelength. It's about a little over an inch. So wrapping around droplets of air, droplets of water in the air from mist or rain is something that it's able to do quite very well. I mean, it's not like a thermal camera or an optical camera where you're going to get blocked by that rain or that fog. Radar sees right through that.
Nice. And will this UI be in the GUI of the IMC?
In the GUI of the IMC. So this right here is being served up from the radar itself. So there's no software to install. This is operating in the web browser. So to access this from the radar, you have a standard IP connection and it is APUE, by the way, back to the question from the other, because it takes less than 35 watts for the total power consumption. it is a PoE, or we can do passive PoEs over a single cable, and then you can access it by the IP address. In this case, we put it on our LAN here, and you just put in the IP address in your browser, and you have access to this. We are also implementing kind of the standard, encryption, SSL type certificates, as well as username and passwords, just like we do with our other radar systems. Any other questions on that?
Paul would like to confirm, so there is no integration in the IMC.
Not directly. So there is, IMC does take the data from our network diode. So if I go back, let me go back to my slide here. So kind of how it works, how the whole system works. The GAX 500, that's the model for the new 3D radar, uses the same APIs as our other sensor systems, and that is then fed into our site level C2 system. So like industrialEnet is using the Converge C2. We have our own called the network IO, and that brings all the data together. In fact, why don't I show you what that looks like. So this is a live system operating over by our building. It's in a park. We've got one radar that's mounted over here, and it's monitoring this whole area with a single radar. This is the same thing with the GAX 500 3D radar. It outputs the track data, which is then goes into the networked IO, so you can have multiple of these together, integrated to a single view, and then that information is placed, with a georeference information, so you can see exactly where it's at, both in three-dimensional space, because now we have a 3D elevation information as well as the 2D over top information. And then you can put in the alarm zones, you can set up different behaviors. In this case, we're showing using video AI to help classify the targets. That's one of the unique things about our networked IO C2 system. It's the first on the market that combines both radar AI as well as video AI for classification. So it's a dual classification process. And you can see as the target is evaluated here, as we get the camera on target, it will then use the video AI to help give additional classification information about it. Did that answer the question?
Certainly hope so. We do have a couple more questions. What is the approximate price of the GAX 500 3D?
Yes, so it is less than $50,000. We sell these through our channel with standard discounts. That is normal with this type of equipment. So if you've been a reseller for us in the past, the same type of discounts are applicable. We're making this so that it can be very competitive to what else is out there in the market. Obviously, it's not a consumer product in that sense, but definitely military and critical infrastructure sites. It gives you that type of peace of mind to know that everything that's going around you, both on the ground as well as in the air.
And what is the range of the GX 500 with CH3D?
Yes, so the GAX 500 3D is, let's go to that slide here. It's 500 meter range on a 3 kilogram drone. So a 3 kilogram drone, if you think about something that's going to carry a payload of like 1 kilogram, or 2 kilograms, then that's something like a DJI Matrice type drone is in that kind of class. Skydio's X10s, those are roughly about 2 kilograms. And if you have a smaller drone, say like a FPV drone, like in our that little video clip there, and what I was showing on the replay on the user interface, those are less than 1 kilogram drones, and so it still functions. It's just the range just decreased. So for like to kind of give you an estimate of that, those less than 1 kilogram FPV drones, we are tracking them in from about 225 meters. So it's roughly about that type of range.
Sounds good. If there are no other questions, I think we can go on to the next portion of the presentation.
All right, I will go on. So again, about the kind of into the integration through our networked I/O, which is an on-site, on-premise. In fact, we have it embedded in things like, let me grab one here. And so we have them embedded in even in a small hub like this. So for tactical situations, very lightweight. We've been able to put it into all kinds of things, and we'll be releasing a new RDID, remote drone ID sensor that has networked I/O built into the sensor itself. So that's a new thing that's coming as well. Let's see, go into that. Let's go skip that one. I also wanted to kind of put it into perspective here. Is with this. Maybe I can show it to you instead. So I was going to show you here. This is the the kind of like the size, weight, and power. Less than 4 kilograms. You can see it behind me, and let's see if I can make myself bigger so you can see it. Stop sharing, and okay. Hope you can see this. Can you see me better now?
Yes, we can.
Okay. Let me grab this here. So this is the GAX 500 3D. As you can see, it's a little bit bigger than this is our C550 extended 1,000 meter range on a person. It's a little bit bigger, not too bad though. It's 16 inches by about 9.5 inches high, 4 inches deep, weighs a little bit over, well, just right around 9 pounds. So 4 kilograms weight. I had it on this little tripod, so it's still deployable. We have kind of standard mounting brackets. It uses our standard Ethernet, ruggedized Ethernet connection right here from all of our kind of current model radars. And like I'm saying, it's APOE at 35 watts. So quite easy to integrate and put into an existing system. Okay, looks like we've got a question about the IP class. This one right here is IP67, so that means it's submersible down to 1 meter for 30 minutes. So definitely, built for all types of environments. Any other questions? Well, if there's not any other questions, I can address one of the other things. There were some more questions about the IMC. And I guess we've got a few people who are familiar with that. We've got a new version of IMC that is also just released. And this one is new in the sense that we have added a few very nice features, including 3D mapping, a 3D map view. So I'll bring this up for you. If you didn't see that, Kevin just said that the LRAD is not ITAR, so that makes it much easier to export. I also should say that this with the 3D radar system, it is also not ITAR, but it falls under the Commerce Department. So if it's an ally, there's like 29 countries that are allied, with the United States, where this is allowed to be exported to without a license. Outside of that, a license can be acquired, and we've done that to other countries. It does take a little bit of time. So here, let me share this.
I have a quick question, Logan. Which VMS platforms or services can this EH3D work with?
Yeah, so all the ones that are supported by our networked IO, which is quite a few. We have integrated with, I think we're up to 20 different VMS systems. And typically that integration is done by two different ways. One is that we send event information over OnVIF or a custom protocol, like with Milestone or Genetec or Vigilon or Exact. And we send this data packet over that triggers the event and then triggers a workflow for inside of the VMS. And then we also export, we take the networked IO user interface and we turn that into an RTSP video stream that can be just consumed like a camera video stream. So then when that event fires, then they can pop up the map that's coming from the networked IO, so they never have to leave the VMS environment. They can get that video stream, bring that in, and then the networked IO automatically queues, the camera onto target. They can queue response systems, and then the operator can decide based off of their SOPs, what is it they should do next. Okay, so this right here is the IMC interface. In the previous versions, in 1.2, it was just a report interface. Now we still have the reporting interface for compliance reports, health reports. You can see here, this is kind of like the health of the whole system, monitoring downtime, tracks and alarm signals, hostiles. So that's all there. But now you can see on a map view, you can see what's going on, both the real-time alerts. That's what you're seeing right here. We're getting real-time alerts that we can pop up and take a look at, say, oh yeah, we got an alarm here at 12 a.m. We in this zone on this system, and we can drill down into those and actually take a look at them with what we call the alarm view. And if we take a look at this, we can see, okay, photographs that are associated with it. You can see if we got a picture. Oh, looks like we got a target. There it is. There's the drone. So we had a drone flying over our building. When was this? Okay, this was just yesterday at almost 8 p.m. Our building's right here, and it flew over. It looks like we tracked this with the remote drone ID, cued the camera on target here, and we're able to alarm on it. Interesting. So that's the alarm review. that brings it together so that the operators can see the health of the system, but also be able to look at real-time alarms as well as historical data as well. So that's kind of the new thing with that. The other new things that are coming out, Networked IO 6.1 is just about to release. We're on the last final phases of testing, and that includes a new video AI model that you saw right here with this drone, which it has a new video AI model for identifying and classifying drones. So that's new, and that's coming out here shortly. So we got a lot of things coming out here. So come see us at ISC West. We're at booth number 13127. We'll have the CH3D radar there. So if you want to come physically take a look at it, we can show it to you. We're competing in a new product showcase there with the SIA. So we'll have that there. Come take a look at it. Again, that's booth 13127. All right, looks like we're coming up to the end of the time here. Is there anything else that any other questions that has come up? Oh yeah, Jamie is posting into the chat our LinkedIn page. If you'd like to see more of these updates, please join there and follow our LinkedIn. And got industrialEnet's up there as well, Kevin.
Yeah, feel free to follow IENET's LinkedIn, my LinkedIn as well. And if you're going to be at ISC West here next week, my team and I will be there as well. We don't have a booth, but we do have some meeting rooms off the floor. So if you're interested, feel free to reach out via LinkedIn, and we can certainly arrange some time. Thanks again for the time. And Logan, thanks so much for having us. Really appreciate it. It was great.
Yeah, hopefully this is informative for everyone, and hope you learned something new. Obviously, this is a brand new technology that we were releasing with this compact holographic 3D radar technology, as well as new versions of our software, and be excited to share with it and meet with you in person if you're at ISC West next week. All right, that will end the meeting. Thanks, everyone. Have a great afternoon.
Thanks, everyone. Thanks, Logan. Take care.